In this video, we're going to continue working with dimensional analysis with some examples. And as a reminder, the basic setup in dimensional analysis is to know what our starting unit is, use our converting factors to get to an ending unit. And the example we used before, number of inches in 2 miles. 2 miles is our starting unit, as I have here. Our ending unit will be inches, and we have that there. We multiply it by a series of converting factors. In this example, I'm using 2 converting factors. The idea when working with these is you want to remember that you want to cancel whenever possible, and then we multiply across. So the first problem is a restaurant chain has sold over 80 billion hamburgers. If a hamburger is a half an inch thick, how tall, in miles, would the stack be? So with this problem, we actually have a couple of starting units. We have a number, 80 billion, and we have a size, half an inch thick. So I'll start with a half an inch, and there's a couple of ways you can write that. Using decimals is okay, or you can use a fraction. And then we'll have 80 billion. Now when we write this, we have to make sure that we are using the full number. So thousands, millions, billions. If I would just write 80, even though I know it's 80 billion, the math is only going to assume 8, or 80, excuse me. And then we know that the hamburger is a half an inch thick. What we want to do is go from inches to feet to miles. Nothing saying that you can't go into your favorite search engine and look for a conversion factor between inches to miles, but here we're gonna take it the long way. So we know that we want to get rid of inches. It's in the numerator, so we know that our conversion factor will be 1 foot per 12 inches. Then we can cancel those. At this point, if we did all the math, we would have the stack in feet, but we want it in miles. So we'll multiply this by 1 mile per 5,280 feet. And feet cancel. And if you do the math, you get 631,313 miles. When doing this on your calculator, probably the best thing to do is to type in the 80 billion, then hit divide 2, divide 12, and divide 5280. So down here I'll write down how you should write this in your calculator. When using the calculator, make sure that you have enough zeros, so you're doing billions, not millions. And then we'll divide by 2, divide by 12, and then divide by 5,280. And then in your calculator, it should give you a number, give you that number. The next problem is going to have us convert a series of starting units to a price in euros. So here we have find the cost in US dollars of 600 widgets if the price is 20 euros per dozen. So we're actually going from euros to US dollars. So we'll start with the quantity. 600 widgets. A widget is just a generic item. It could be anything. It could be cars, it could be pencils. And then we're going to multiply it by 20 euros. Now they're buying it per dozen. So per dozen. If it was just 20 euros, then we wouldn't have to worry about putting the per dozen. But this per is very important. At this point, we haven't canceled anything yet, and that's okay. Sometimes you're going to have problems where you don't cancel right away. So now what we want to do is convert the dozens to and the widgets. So 1 dozen per 12 widgets. So we canceled the dozen and we've canceled the widgets. So at this point, all we know is the cost in euros. But the problem asked us to find the cost in US dollars. So we're going to do another conversion factor. And we need to know what a euro and a dollar equal. So on May 13th, 2015, I went to Google and asked it to tell me how many euros there are, excuse me, how many dollars there are to a euro. So I found 1 euro equals $1.14 US. And you put the US so that you're confirming that people understand that the final unit is currency, as in United States currency. So I did euro to US dollar. If you did dollar to euro, you would get a number, a decimal that would still work. So here we're going to put the $1.14 US on the top per 1 euro. And we cancel those out. And then if we multiply across and then divide by 12, we get 1140. Now I also looked for 1 US dollar and how many euros that was, and that was 0.88. So at this point, we could just multiply by $1 US per 0.88 euros. They would still cancel out. We would just replace this and this. And that gives us 1136. A few bucks off, but the conversion of the decimal there was rounded to the second decimal place, so that's why we have a little bit of a discrepancy there. The next problem, we're going to convert speed into something that makes a little more sense. So a pyroclastic flows are high-speed avalanches of volcanic gases and ash that accompany some volcanic eruptions. They travel at speeds of 10 meters per second to 100 meters per second. Could you outrun a pyroclastic flow? We're going to assume that the one we're working with is 10 meters per second. When something travels very, very quickly, sometimes they will use feet per second or meters per second. In the space industry, they'll do feet or meters per second, but we want to do miles per hour. So we will start with 10 meters per second, and we're going to need to do some conversions. What we want to go is from meters to miles and seconds to hours. So we're going to convert seconds into hours. There are 3,600 seconds in 1 hour. And then we want to convert meters into miles. There is 1 mile 14.9 meters. And we can cancel those out. And this gives us 22.4 miles per hour. I don't think you're going to be able to outrun it. Maybe if you're on a bike or a car, you might be able to do that. Now you'll notice that when I did this problem, I did the time first and then the distance second. Doesn't really matter what you do first. Multiplication does not matter what is multiplied first. You could have swapped these two and still got a correct answer.